Welcome to Learn with Amine. In this video, we will program for one of the frequently asked interview question, which is finding minimum in rotated sorted array. So in this problem, an array of length n is given and it is already sorted in ascending order. So make a note that this is sorted in ascending order. It comes to our use while we are programming. And further it is explained about how the array, if it is rotated 4 times, what happens. So for example, if this row is rotated, so that means the 0 will occupy index 1 if it is rotated 1 time, and 1 occupies the index 2, and 2 occupies the index 3, and 4 occupies the index 4, 5 occupies the index 6, 6 occupies the index 7, and 7 occupies the index 0. So that is how the rotation happens 1 time, and the same way you can rotate it 4 times and 7 times. So basically, if we look at the example, it is asking us to yield or output the minimum value in the already sorted array, and it is not asking you how to yield the number of rotations, but it's just asking us to return the minimum value. Okay, the minimum value here is 1, and the minimum value here is 0, and the minimum value here is 11. So basically you cannot use the function min of nums, but you need to write a program, and you have to do that in O of log n. So that is actually given in the program description. You must write an algorithm that runs in the time complexity of big O of log n. Okay, big O of log n. What do you remember from O of log n? It is the time complexity of binary search problem. Binary search problem is also finding the minimum, and here the array is already sorted, and in binary search we require the array to be sorted. Okay, so that's it. So we will be using binary search in order to find out the minimum in this problem description. So let me explain you the dry run. Okay, so let us take the example which is given 4 5 6 7 0 1 2. This is the array nums, and we need to find out the minimum value, which is basically 0. So initial state, we assume left is equal to 0 and right is equal to 6, because it is length of nums minus 1. And what would be the mid value? The mid value would be the index 3, and the numbers at that mid value is basically 7, and the numbers at the index 6 is equal to 2. Now if we look at numbers of mid and numbers on right, if we compare them, so is it less than or greater than? It is definitely greater than. Okay, so what does it mean? It means that our lower values are located towards the right index. It is not located towards the mid index. So that's why we will be shifting our left index to mid plus 1. So that is what we are doing. We are updating left equal to mid plus 1, which is basically 4. And now we assume left equal to 4, right equal to 6, and then we calculate the mid value, which is 5. Numbers at index 5 is equal to 1, and the numbers at right is equal to 2. Now if we compare these two values, numbers of mid is less than numbers of right, so that means the lower values are towards the index mid. So we update right is equal to mid equal to 4. Okay, now what happens in this? In the third iteration, after the third iteration, left equal to 4, right equal to 4, and we can stop the loop as left is no longer less than right, and the algorithm can return numbers of left which is equal to 0. So for the input nums, the output of the algorithms will be 0, which is correct. And here the time complexity and the space complexity that we would obtain in this binary search algorithm would be time complexity is big O of log n, space complexity is equal to O of 1, because we are only storing one value. So let us jump into the program right away. Let us define a class solution and then define a function find min of self comma nums. So nums will be the array that we will pass as the argument. So left comma right, we will be assigning it to 0, and this will be assigned to length of numbers minus 1, that is the maximum value of the index in the array nums. And then we will be applying the condition while left is less than right. Okay, in that case we will be calculating the mid value as left of right minus left divided by 2. This is the integer division, so it will only return the integral part of the value. Instead of 3.5 it will return 3. Okay, next what we will do is we will be comparing the nums of mid and the nums of right. Okay, so the first condition that we will check is less than condition. Now if nums of mid is less than nums of right, so what does it mean? The lower values are towards the middle index, so we'll be shifting the right to mid because we want to search our number in the left part of the array. Okay, now else what we will be doing, we will be writing left is equal to mid plus 1. Okay, so and ultimately we will be returning nums of left. Okay, and this would be the minimum value that is found in the array, and this would be with the time complexity of O of log n, because this is binary search, and the space complexity is O of 1 because we are not using extra space. And another thing is how many rotations are required. So basically the index left is the number of rotations that are required. So for this program we looked at the minimum value, which was numbers of 4, that is an element at the index of 4. So the number of rotations required is also 4. Let us run some test cases. So my object will be equal to solution. Okay, and then I take several of the numbers. Okay, so these are the numbers arrays that I will be considering. So here the minimum value is 1, here the minimum value is 0, here the minimum value is 11. So if we run this program, go to tools, then control B, build, so 1, 0 and 11. So this is our program for finding minimum in rotated sorted array, and this is using binary search, and it is having the complexity, time complexity of O of log n. If you like this video series, please comment on the video, like, share and subscribe. Thank you, take care and bye bye.